So you have learned the basic of number patterns. In this lesson, you will learn how to find the common difference when some numbers are missing. And what do I mean by this? You will see the question, then you will understand what I mean by when some numbers are missing. And these are the questions that you will typically see in O-level. So the objective of today is you will learn how to find a common difference when some numbers are missing. And the key is you just divide. So copy this down inside your notebook. And when you are done, let us continue. So a typical question will look like this. In a sequence, the same number is added each time to obtain the next term. Find the value of x, y, z is part 1. So this is what I mean by when some numbers are missing. Here you might be compelled to divide the difference of 23 and 11 by 3. But let's see whether this is true or not. So first thing is, you know that number pattern, right? From 11 to x, it is plus d. Because this question said added, so we plus. From x to y, we plus d again. From y to z, we plus d again because it's a common difference. And finally, from z to 23, we plus d again. So you can see that from 11 to 23, we actually plus how many d? 1, 2, 3, 4. So 11 plus 4d will give me 23. Now, doesn't this look familiar? Doesn't this look like something you have learned a few months before, which is solving of equation? So very simple. You have the gym leader down here and the sidekick down here. Which one will you thunderbolt first? You will thunderbolt the 11, so we move the 11 over, and we will get 4d is equals to 23 minus 11. And 4d will be equals to 12. And finally, we can solve for d. D will be equals to 12 divided by 4, and we will get 3. So since d is equals to 3, x will be equals to 11 plus 3, which is equals to 14. Then y will be equals to 17. Then z will be equals to 20. And 20 plus 3 will give me 23. So this will definitely be my answer. Part B is write down an expression for the nth term of this sequence. This is something that we learned in our previous video. Remember the general formula is Tn, which is the nth term, is equals to the term 0 plus common difference times n. So we know that d is equals to 3. Okay, we have to find term 0. So something plus 3 is equals to 11. So from here we can see that term 0 is equals to 11 minus 3, which will give us 8. So all we have to do is to write down term n, or the n term is equals to term 0, which is 8, plus the common difference is the additional of 3 and n. So this will be my answer for part B. Now explain why 256 is not a term of this sequence. What does this question mean? This question is actually quite simple. You just have to prove that term n can never be equals to 256. What do I mean? So what I want to prove is this: term n is not equal to 256. And term n, which we found earlier, is 8 plus 3n. So let us write down 8 plus 3n is equals to 256. So for this to be true, n will not be a whole number. Because only when it's a whole number will you get a number in this sequence. So very simple, 3n will be equals to 256 minus 8. 3n will be equals to 248, and n is equals to 248 divided by 3, which will give me 8. The 2 and 2 over 3. So how do I explain? Since n is not a whole number, when Tn is equals to 256, 256 is not a term of this sequence. Okay, and that's all. That's the explanation. You must show mathematically that n is not a whole number. Because only when it's a whole number, it can be part of the number pattern. Because you only have term 1, term 2, term 3, term 4, term 5, you do not have term 1.5, 1.9. So please copy down this example and we will try another question. So the next question is pretty similar to the previous question. The only difference is, or the main difference is, it is subtract instead of addition. Now, you might want to pause the video and try it out yourself. And I hope that you have tried it out. You can fast forward to see whether you got the correct answer. If not, you can follow after me and try to do this question. So 39 to 11, we know that it is minus d, minus d, minus d, and finally minus d again is equals to 11. So from here, we can see that 39 minus 4d will be equals to 11. So I would like to bring my 11 over and negative 4d over so that I can make this negative 4d equals to positive 4d. So I will do this. Minus 11 is equals to negative 4. I move over, it will become a positive 4. Like this, it will be easy for me to work with. So I will have 4d is equals to 28 and d will be equals to 7. Now just take note, even though that d is equals to 7, 39 minus d, so it's 39 minus 7 rather than 39 plus 7, even though this one is a positive d. So let's calculate PQR. P will be equals to 39 minus away 7, which will give me 32. Q is equals to 32 minus 7, which will give me 25. And finally, R will be equals to 25 minus away 7, which will give me 18. So one thing to take note is you can always check the answer. 18 minus away 7, do I get 11? Yes, I do. So I know that I am correct. Part B is just finding the n term of the series. So Tn is equals to term 0 plus dn. Term d we have already found, but in this case it's not 7. It is actually -7 because we can see that it is negative down here. And term 0 will be equals to 39 plus 7 because it is the reverse of -7, and I'll get 46. So term n will be equals to 46. Now, like I said, it is minus d, so common difference is actually -7n, and this will be my answer. Explain why -246 is not a term of this sequence. Similar to previous question, you will want to prove that term n is not -246, where n have to be a whole number. So you have to prove this, not equals to. So term n you just found is 46 minus 7n. So 46 minus 7n, okay, is equals to -246. Then 46 plus 246 is equals to 7n. 7n will be equals to 246 plus 46, which will give me 292. So n will be equals to 292 over 7. Does it give me a whole number? No, it doesn't. It just gives me 41 and 5 over 7. So your explanation, because the question asks us to explain, since and when Tn is not equals to -246 is not a whole number, -246 is not a term of this sequence. Okay, I hope that you have gotten this question correct. And for your